Hi, my name is Roy Nunez, and today I will present a web application that my team and I developed using the Spring Boot framework for the REST API backend server and the open source Angular framework for the front end view for the client side. This is essentially a mock pizza shop website that allows users of the website to purchase items such as soda, pizza, desserts, and so forth, and it allows administrators of the website to dynamically add different categories of products, different products, manage order and order history. My team's name is Team Alpha, and we're comprised of the following members: Terry Johnson, our database engineer; Quinn Bieber, our lead front end developer; Danny Murtaugh, our full stack developer; and myself, Roy Nunez, the project lead and developer. Now, during this presentation, I'll go over a mock-up of a web application's front end, a UML diagram of the application's functionalities, an overview of an Angular front end, and an overview of a Spring Boot backend. So here's a mock-up of our Pizza Shop website, and I will start off with our homepage where we will make use of a carousel that will rotate through different images and incorporate the use of different marketing tools that will market our products and our webpage. Now I'll go on to our menu page, and here you can see different categories of products that are for sale. We will also make use of a deals page where we will have different deals that are going on for a particular week or month, and these can be either dynamically added by the administrative user, or we can automate the generation of them. Now, once a customer is ready to move on with an order, he or she can visit our order page where we can still modify the quantity of items we wish to purchase, and he or she can view the total amount of that complete order. In the next phase, he or she can enter their credit card details, and once the customer is ready to place an order, they can go ahead and click on confirm, and this will generate a payment successful notification as well as an order confirmation number. Now, we also plan to have a login page where the customer can use their username and password to log in. This will keep track of rewards points earned through purchases. Now, if they don't have an account, they can always register and create one. On the admin side, here we'll be able to see the items for sale. We can add and delete as needed. Here we see our deals where we can dynamically add deals and our orders. When they come in, we can manage them and ship them accordingly. Here we have the Unified Modeling Language schematic, or the UML diagram of our web application. And it's comprised of the several components: the user, which interacts with the view component; the application itself, which behind the scene is managed by the Java software we develop in Spring Boot; and a database which was developed in MySQL; and the administrative side, which is able to add different categories, different products, and manage orders as well. Now, the user can interact with several pages on the view side. They can see the user homepage as well as the menu tab. Now, when the customer interacts with the menu tab, they will be able to see the amount of products that are available on the different categories that they choose from. When they do so, the server retrieves all products that are currently in the database, which are in turn managed by the administrative side of the application. These products are retrieved and shown to the user, which can then choose to add them to the cart. Now, once the customer decides to go on forward with the order, they can go ahead and check out and make the order purchase by entering their account info. Once the user confirms that this order is to be placed, This will go on to the manager, the administrative side, and the administrator will be able to view all current orders that are not delivered. It is up to them to decide on which orders are to be delivered, and they can do so on their administrative side. Now, if the user is logged in, he or she will earn reward points based on the amount of the order. If they do so, this is saved as well in our database. They can go ahead and log in with the username and password or register an account to sign in. This is done through the security configurations of our Spring Boot application. If the user's info is correct, the user can go ahead and log in, and this will store their order and the rewards earned for their purchase. This is the current version of our web application. This is our home page, and we're going to go straight to our menu where we have most of the features. Here's our categories. We can choose from different categories here. We're going to go ahead and start in order. We're going to add the Mountain Dew. Actually, let's add a Coke in there. We can add a pizza as well. 3 cheese. Let's go ahead and add a dessert. That looks yummy. And some wings. Now, if the customer decides, they can move forward through the checkout. Now, say if the customer decides to opt out of the Oreo Pizza Deluxe, we can do that, and then we can also add an additional set of wings. As you can see, this was updated automatically. Now we can go ahead and check out, and here we can just provide our address. Now this automatic credit card filling is disabled because this form does not have a secure connection, and we don't have a secure connection yet, but plan to do so in the future. And let's go ahead and just put random numbers in there for the meantime, and here we can place our order, and that's done. Now we have an About Us page where we have links that can be followed. We also have a login page where we can log into our account. Here are the steps we took to develop our Angular setup. We wrote the models that include the product, model, order, customer, and repository. We then added the repository and model to the app.component.cs file, and this includes a repository constructor. We then implemented the CRUD operations, get, post, put, and delete verbs for products in the controller, repository, app.component.cs, and the app.component.html. We built the structure for the website, which includes the home page, About Us page, and shopping page, and this implemented the use of the Bootstrap navbar, which routed all the pages together from the navbar. We built the store in its implementation in items like the shopping cart and the checkout process. We then created the admin page, and we implemented HTML, CSS, Bootstrap technologies for aesthetics. I'm now going to go over our Angular software in depth, but here you can see the different pages that we developed, including our customer registration, home, models, and so forth. Down here is an app bar. You can see we have the TS components, HTML, and so forth. Currently our project is running. So I'll go over the steps that we went through to set up our REST API. First, I created the Maven project. Then I used the Spring initializer to include our dependencies, which are the starter web dependency, the starter security, Hibernate, MySQL, and the starter JDBC. And Terry set up the database and once you set up the database, I included the database URL and our credentials to the application in the applications.properties file. Then we set up the models, which include the customer, product, order line, and customer login classes. And then we set up our data transfer object classes, which include the cart, the checkout, the customer, the order confirmation, the product, and the product selection. Then we set up the repositories, which include the customer, order line, and product repository. And we set up our two mappers, the customer mapper and the product mapper. Then we set up our service classes, which include the customer, order, product, customer detail service, implementation, security service, and security service implementation. We set up the configuration classes, particularly the CORS configuration. And then we set up the controller classes, the customer controller, which handles the customers, their login details, and registration details. And then the product controller, which handled the products and product categories. We also have the session controller, which handles the carts, checkouts, and front-end controllers. Then I set up the security configurations with the web security configuration class, and they also utilize the bcrypt password encoder. They encrypt and decrypted passwords. And after that, we tested each CRUD request with Postman. So I'll go over the web security configuration. We use the Spring Boot security. I use the Spring Boot security dependency, which allows security at the web application level. Now, by default, this dependency provides filter mapping that intercepts all HTTP requests and will allow access to certain URLs to specified users who are logged into an HTTP session and restrict access accordingly. So this on line 15, this configuration annotation tells Spring that this is a configuration class. While on line 16, this enable web security annotation tells Spring Security that this is a web security configuration class. On line 17, we extend the web security configure adapter and this allows an HTTP security object for authorization. And here we implement the use of the user detail service interface, which includes a method that returns an object of the user details with username and passwords for the principal object. In this case, the principal object is the currently logged in user. And this bean allows us to use this is the bcrypt password encoder class, which provides an additional layer of security for the user's passwords, since we do not want a clear text password that can be vulnerable. This essentially encrypts the passwords and allows them to be decrypted when used. Therefore, only the user and not the administrator will be able to see the real password. Now, to tell the authentication manager what to do, we use the authentication manager builder for this configuration. And in this particular case, we use the HTTP security class and instantiate an object of this class. We pass this object to the configuration class that takes this as an argument. Now, the HTTP authorized request opens up what is called method chaining, and this allows us to map authorized requests, while the ant matchers allows us to specify permissions to those URL requests, and we end off here with permit all, which allows access to all the aforementioned paths and ant matchers. To end this method chaining, we include the and end with our form login, which provides a default login page for Spring Boot security. Here we have the authentication builder manager, and we created an object of that class, and we use the in-memory authentication method to let Spring Security know we're using the database in memory, and this allows us to pass in the username and password. So to set up the REST API, we did the following. I created a Maven project. I'll use spring.initializer.io to set up our dependencies, which included the starter web, starter security, Hibernate, MySQL, and starter-based JDBC. Now, Terry set up the database, and I included the URL and the credentials to the database in the application.properties file. And then my team and I set up the models that includes the customer, product, order line, and customer login. Then we set up the DTO classes that include the cart, checkout, customer, order confirmation, product, and product selection DTOs. We set up the customer, order line, and product repositories, and then we set up two mappers, the customer mapper and the product mapper. And then we set up the server classes, which included our business logic for the customer, order, product, customer detail service, security service, and security service implementation. We set up the configuration class, the course configuration particularly, and then we set up different controller classes, the customer, the product controller, and a session controller, which handles the carts, checkouts, and front-end controllers. Then I set up the security configurations within the web security configuration file, and I used the bcrypt password encoder class to encrypt passwords. We tested our CRUD request with Postman, and then linked up to our front-end component. So I'll go over this customer API controller, which serves the GET request for our customer table. And here we have several requests, including the GET request to retrieve all customers. We can retrieve one customer individually by providing a customer ID. We can post new customers, modify existing customers, delete existing customers, as well as get the map request for our registration and login pages. Now I'll show you a few of these GET requests using Postman to test our API. So we're going to go ahead and retrieve all customers, and here we go. Only have a few customers in our database currently. Now, if you wanted to retrieve one individually, we'll go ahead and retrieve 113. And if we wanted to post a new customer, we'll just change the information here in the body. Oops. And password remains Collabora. Give them another 1,000, and we'll keep this address for now, and let's go ahead and post this. Oops. So we can't provide a user ID because it generates one for us. And here we go. And if we wanted to delete one, we can choose any one of these. Let's go with number 90. And as you can see, our status is 200, which means okay. We have successfully deleted a customer. Now, if you wanted to test our login API, we will go ahead to a different port. Since this hasn't been connected to the Angular framework yet, but I just wanted to demonstrate how we have a login feature now. So if I go ahead and enter incorrect credentials, I'll be given the bad credentials notification, which is by default provided by Spring Security. Now, if I enter the password, the correct password, here I'm able to get this error. And the only reason I'm getting a 404 error and not a page is because there's no explicit page that's dedicated to this path. But as you can see, the page was not found, but we were able to bypass the security. And after I set up my customer control class and this the baseline for this REST API, my team members helped me fill in some of the other classes, including the product controller, session controller, and some of the other DTOs. We all work collaboratively to get all these classes done, but as you can see, there are quite a few: the mappers, the model classes, the repository classes, and all the service classes. So this project is hosted on GitHub. You can visit this link, which I'll post below, to see all the details related to this project. I'd like to thank Reno Adolfi for all the help and mentoring he's provided, the Collaborate program, and as well as Koshu Katago at Java Brains for providing these two courses, which were instrumental in helping us develop this web application. Thank you for listening. Please subscribe if you like, and like if you like.